Okay, guys, so today we're going to review, we're going to go over the trapezoid homework, see if you had any questions with that. We're going to review for a quiz you're going to have tomorrow, and it's the same format as what's in your notes today. So whatever we don't finish in class, we need to finish for homework, and then we'll go over it in the beginning of the class, and then we'll have a quiz after that, okay? So the only homework will be to finish this little practice, okay? Now, for the do now today, what I want you to do is try to draw a graph where using a left-hand Riemann sum we'd wind up with an under approximation, and then draw another graph where using a left-hand Riemann sum would wind up give you an over approximation, and see if looking at what you came up with you can figure out. You can use a word to describe what's going on. When a left-hand Riemann sum will give you an under approximation, and when a left-hand Riemann sum will give you an over approximation. So think about what it'd have to look like, and same thing for using a right-hand Riemann sum. And then go on and do that for trapezoids. Think about what the graph would look like where trapezoids would give you an under or over approximation. I'm going to check the trapezoid homework while you enjoy that. All right, guys, show me with your hand what you think a graph would have to look like for a left-hand Riemann sum to give you an under approximation. No, somebody will. Right. Oh, yeah, that was okay. I'm thinking of it backwards here. Nope. Nope. For the rectangles? Yeah, for this first, for the rectangles to always give you an under approximation. What are you doing there? Okay, yeah, actually. Yeah, you're right, and you're right. All right, so if you draw something like this. You did? So if you tried to use if the left side determined the height, do you see how that would give you an under approximation? If the left side's lower. Yeah, so what kind of a function does it have to be? What is this function doing? Increasing. Yeah. Nice. All right, so if you're using a left-hand Riemann sum and you have an over approximation, what would that look like? Decreasing. Because that would mean that the left side's got to be higher, right?
Oh, I get it.
Get it? So if it's decreasing, you'll wind up with an over approximation. What kind of a function would have a right-hand Riemann sum that gives you an under approximation? Say again? Decreasing. So if it's decreasing, now the right side is lower. So if you're using the right side to determine, oops, I don't know what I just did there, the height of every rectangle, of an under approximation. So decreasing. And the right-hand Riemann sum will be over if the function is increasing. If the right side's higher, using the right side is going to give you an over approximation. The concavity doesn't matter. It does not matter. All right, so what do we say? Increasing. I want that to make sense. I don't want you to have to memorize that. I just want you to be able to see it. But if you can't see it, just memorize it. Just, it'd be better if you understand it. Right? If the right side will be an over approximation if the right side's higher. It'll be an under approximation if the right side's lower. Does that make sense or no? Okay. All right, now, so whenever you're asked, if a right-hand or a left-hand Riemann sum is an under or over approximation, all you have to care about is the function increasing or decreasing, and you got your answer. So you got to think about increasing, decreasing. But with trapezoids, it's not about the increasing or decreasing. This one's about the concavity. With trapezoids, when are you going to wind up with an under approximation? Yeah, if you've got a graph that's concave down, and you're using trapezoids to approximate the area underneath, you're going to wind up with an under approximation. Like that, in the way. So concave down, you're using trapezoids, it'll be an under approximation. And when will trapezoids give you an over approximation? Uh-huh. So you use trapezoids. Whatever. Concave up. So under over approximation with trapezoids, it's about the concavity. With rectangles, it all depends on the increase and decreasing. You got it? Oh yeah. Let's see how you did on that homework. Oh, good. I won't note this other. I just hear me saying good. If you have negative 18.5 for number 6, don't worry, it's the same thing. Did you? Oh boy. Yeah. I'm going to go over number 7 for sure. Is anyone still checking their answers? Okay. Got baby scissors. You're not cutting your hair, are you? Okay. I think that came out on my tape. All right. You got them down? Yes. Okay. Oh my gosh. 7, 8, and there was one before that, 5. Okay, number 5. First thing you got to look for is the height going to be the same for all the trapezoids? Yes, so you can factor it out. So what goes out front? 1/2, and what is that height? That common height is 2. See how they're all different by 2? That's the height. Now, when you have the common height, remember we're going to add up the bases and all the internal ones are going to be doubled. So what's the first number? All right, 8. Then what? Plus 2 times 7, 8, 7. 7 plus 8 plus 7, close it, plus 9. And that equals whatever we said it equals. 61. Okay. All right. 61. I'm going to erase, okay? Number 7. Where's my, oh, 7. Okay, we look at this one. Do they have a common height? No, this guy messes it up, right? It was 3, 3, woohoo, 3, oh, 1. So when that happens, what's the only thing you can pull out? Half, right? You just didn't. You can just keep the half in there, do them all separately if you want. That's fine. But if you do pull out the half, you still have to do the height times the sum of the bases. The height, that's the difference in the x's, the sum of the bases, the sum of the y's. So for the first trapezoid, we've got 3 for the height. What do I write for sum of the bases? 3 plus 5. Then we move on to the next trapezoid. 3 times 5 plus 6. Moving on. 3 times 6 plus 4. And then the last one, 1 4 plus 5. So we're going to do all that and multiply by a half, and we'll get our answer. Okay, and then you wanted to see 8? Do we have a common height for that one, or is it different? Oh, man. Okay, so since the difference in the x values is not always the same, what's the only thing we can pull out? Yeah. So we have 1/2. Now we have to do the height times the sum of the bases for each trapezoid. So what are we writing? So this looks like the same one. 3 times 5 plus 3. Okay. Next one. Oh, no, it's not. 3 plus 4. Good. 1 times 4 plus 2. Plus 1. 2 plus 3. And then the last one. Plus 2 times 3 plus 5. So you have to do all that. Multiply by a half. Good stuff. Alrighty. Ready? Any other questions on this? Or on the rectangles? Anything else you need to see before? Let's go to it, because we're going to review everything right now. I was trying to put the answers under there, but I didn't have them all. So, it's just decorative. Yeah. I have a few of the answers under there. I was trying to do that before you came in. No, it's just decorative, making it nice to look at here. Okay, so here's the deal. We got the graph of f of x equals x squared plus 1. And we want to approximate the area under that parabola from -2 to 6 using 4 equal subdivisions. So what's the first thing we got to find? The width, okay, for our rectangles. And what is that going to be? 2, because you take 6 minus -2 over 4 and 2. So as far as getting our area approximations for left or right or trapezoids, we got to know the y's at particular x values. What's the first x value? Yeah, the -2. You start at A. You want to know, you're really finding out the endpoints of each of your subintervals. So you're starting at -2. We figured out the width is 2. So what would be the endpoint of my first subinterval? 0. And then the next 2, 4, 6. And if you did it right, you should wind up at your B value. Any question where we're getting those numbers? Now, if you wanted to, you could always set up your table, have your table start value -2, and your delta table would be, what would you put into your calculator if you set up your table? We're not doing it. We're just, when you set your table up, you'd make it 2, whatever the width is, whatever B minus A over N is. We don't even need the calculator for this one. I just thought it'd be fun. But if you have the program, you could definitely check your answers with the program. Okay. So let's just do this one by hand because it's so easy. We're just going to square x value and add 1. So when x is -2, what's y? And when x is 0, and 2, and 4. All right. Now, for left and right, that's all the information you need. You don't have to see the graph. Right? So let's just go ahead. If you're with the rectangles, if they all have the same width, which they do, what do you write down first? Well, what is your width here? It's the same width, so we can factor that out. Now, we're using 4 rectangles. We better only have 4 heights in here, not 5. So don't just write all those y's down, right? So the first rectangle, the x's go from -2 to 0. Whose y coordinate are you going to use for the height of your first rectangle? you're going to use the 5 because it's the y coordinate of -2, which is on the left. Okay, the height of the first rectangle is 5. How about the second rectangle? And the third. Do I write down anything else? Nope, close it. See, this one I have there. I was going to be really cool. I was going to say, yeah, look. Because then I won't have to figure it out every time. But it's a big quiz. Okay. Sorry. It was 56, right? I hope. All right. Moving on to the right end points. What about that width? Is that changing? No, because we still have 4 subintervals in the same from -2 to 6. So it's still 2. But we're not going to use those same 4 heights. What's the height of my first rectangle going to be? 1. It's going from -2 to 0. 0 is on the right. We're using the y coordinate 0, which is 1. What about for the next one? 5, and then 37. Ooh. I have this one too. Anyone get? You got 120? Oh yeah, it is 120. 120. See then? Are you all right with those two? So yeah, if you would put that into your y1 and you ran the program, you could have checked these 2 answers. But if you just write down 56 and 120, and I don't see what numbers you used, that's not good. That's not good. I'm hiding it again. Now, skip midpoints for 1 second. For midpoints, I'm going to need some other y coordinates. What else can I do just with those? Trapezoids. We can do the trapezoids. Let's do those. Trapezoids. Do all these trapezoids have the same height? Yep. So we can pull out the 1/2 and the height. Love it. So what do I write down first? 1/2. Don't forget the 1/2. And then the height, which we said was 2. It's the same as the width of the rectangle. All right. What do we write? What are the sum? Remember when you have the sum of the bases and they all have the same height, just double the internal bases. So 5 plus, before you forget it. Yeah, when they have that common height, you pull that, you don't have to do them all separately like that. Just remember all the internal ones are doubles. So 2 times, what am I writing here? Close it. Okay, this one I don't have. I have an 88 and a 68. Anyone want to? I think it's an 88 for trapezoids. I'm just going to believe whatever you say. So I'm just going to say 88. Anyone else get that? Yeah? Okay. What should we do next? Let's go back to the midpoint. Let's do it. So the thing is, we know the endpoints of each of our subintervals. No, I'm going to erase this because I need a little more room. I want to get rid of you, kid. Okay. So we have our x's at the endpoint, -2, 0, 2, 4, and 6. We don't want the y coordinates of those to be the heights. Right? For our first, the width is still going to be the same. You're still fitting 4 rectangles in there, so we can factor out the 2. Okay? But whose y coordinate do we want for the first rectangle? Yeah, it has to be f of -1. We'll figure that out in a minute. It's too much to do right now. Whose y coordinate do we want for the height of the second rectangle? That's what I'm talking about. And the third rectangle, f of 3. And the last rectangle, f of 5. So we have to get these values. We have to plug them into our function. It was just we square them and add 1, so that wasn't too bad. Just move some of this stuff out of the way. So we have 2 times, what's f of negative 1 if you square it and add 1? 2 plus f of 1, do it again. Oh, you're up to this one. Okay, that's 10. Still 4. Ooh, I know this one. What did you get? 80. Okay. So we did the left, right trapezoids just with the end, using the y coordinates at the endpoints of our subintervals. Midpoints, we had to go in between, get those y's. Now for inscribed and circumscribed, you really need to know what the graph looks like. All right, so thankfully this is a nice, easy one. Because remember, for inscribed, you're choosing the smallest value of y to be the height. So you really want to know. Now this is y equals x squared plus 1. So I got to cross this out just for a minute so I have more room. I have no room. Oh, you know what? I'll extend the page. Here we go. Doing the inscribed. So y equals x squared plus 1, just a parabola, right? Just moved up 1. So it goes down. You just have to know when it's decreasing, when it's increasing, basically. So negative 2. We still have these important x values. The endpoints of our subintervals are negative 2, 0, 2, 4, and 6. We're still using 4 rectangles. What's the width of each of our rectangles? 2. So this is for inscribed. We've got the 2 times. Now, remember for inscribed, you have to look at each subinterval and look at the y coordinates on the graph and see where the smallest y is. Look for the lowest point of the graph over that interval. So from negative 2 to 0, who's got the smallest y value? At what x value do we have? At 0. So we want f of 0. F of 0 is going to be the height of our first rectangle. I'll write f of 0 here, and then we'll fill them in. Now for the next subinterval from 0 to 2, you look at the graph. It's increasing. So where do you have the smallest y value? At 0. So you're taking the y coordinate at 0 to be the height because all these other y's are greater. And you're for inscribed, you're going, so f of 0. So you just flip-flop because this lower side was on the right, a 0, and then for the next rectangle, it's on the left. That's why it was at 0 again. What about from 2 to 4? At 2, f of 2. That'll be the y we use to be the height for this one. And the height of the last one will be f of 4. Oops, that's not so high. And we have all these values. We said f of 0 was 1, right? Plus 1 plus 5 plus 17. Oh, I remember what it is. But tell me what you guys get. 48? Yeah, I think it was 48, right? That's for inscribed. Notice all the rectangles. So just go up to the curve, touch it. One more. Ready? I'm going to be lazy. I'm going to use the same graph. I'll just make more rectangles in another color. No, can you do it over? Okay. Right. Okay, but it's the same graph, so it comes down and up. So that wasn't so good. Okay. So the width is still going to be 2. All right, first rectangle. The x's go from negative 2 to 0. Who's got the greatest y value? A negative 2. So we're going to take the y at negative 2 to be the height of the first one. F of negative 2. That's the height of our first rectangle. How about for the next rectangle? We're looking for the greatest y. Where does it occur? At 2. At 2. Next one, f of 4. We're always looking for the hot corner. And the last one, the f of 6. And we fill all these in. We have 2 times 5 plus 5 plus 17 plus 37. I think I remember it, but what do you think? I think it was 128. Oh, okay. I was thinking it was 120, so I was wrong. 128. Yeah, correct. All right, so that one we were given the actual function in the interval, and we found all those different approximations. And in any of these, whether you're using rectangles, oh, I didn't want to do that. Whether you're using rectangles or trapezoid, with any of these different ways to approximate, could we do with the number of rectangles or trapezoids to make our approximation more accurate? Make the width smaller. We're going to make the width smaller. That was for you. You didn't even appreciate it. So the number of rectangles or trapezoids would have to what? Increase. So if we just increase n, where n is the number of rectangles or trapezoids, the more you have, the better the approximation. So the answer to this one is increase n to infinity. Have an infinite number of them. Then you got the exact area. Just say increase of. All right. The other one that I definitely want to be able to see with you in class today is number 2. I think you'll find 3 and 4 easy, but number 2. It's a table problem, right? But if you look at it, we want to approximate the area under this graph from 0 to 24 using 4 equal subdivisions. So what's the width of every one of my rectangles going to be? 6, right? When you get your width for the rectangles, we call it the width, 24 minus 0 over 4 equals 6. So if this table wasn't given to me, which x values would I have just normally used? Because for the endpoints of your subintervals, the first subinterval starts at 0 and goes to 6, right? Because it's 6. And then what would be the next one we'd need? Yeah. And this is an AP question, so that's why I want you to see this. And add another 6, we would have the 18 and the 24. We don't need it yet, but we will need it. But for now, if we need to get a left-hand Riemann sum, we're using 4 rectangles, we first are going to write down the width. And I got to tell you, kids, every time I give a question like this, I have the kids who say, oh, yeah, left. They just don't use the last one, and they write down every one of these numbers. So for 4 rectangles, they wind up giving me like 8 or 9, whatever it is, heights. How many heights should you have if you're trying to get the area of 4 rectangles? 4, right? So we just got to choose the correct 4. So what's the height of remember, the first rectangle, the x's or t's go from 0 to 6. What's the height of our first rectangle going to be with the left? The 9.6, because 0 is on the left. It's 9.6. How about the second rectangle? The t's go from 6 to 12. Whose y do we want? We want the y of 6. So that's 10.8. The next rectangle, we're going to use the 11.4. And then the last one, 10.7. Because we're using the left. If you're going from 18 to 24, all right, What? B is the same? Yeah, right. Oh, it's the same answer? Oh, yeah, that could happen, but that would just be, I just happened to pick one. Oh, wait, I don't know if you're doing, I'm not sure. Did anyone get an answer for this? I think I had a decimal. Oh, yeah, this one didn't have a decimal. Okay, this was 255. You're right. Okay. See, I think you're doing some. That M here, what are we supposed to use to determine the heights? Midpoint. Oh, that's just rectangle approximation method. So we're going to use the midpoints. Now, what's the width of each rectangle going to be still? It's still 6. And I'm still using 4 rectangles, so I better only have 4 heights. Now we find out those extra points are relevant. This is why we needed them. Because so for our first rectangle, the times are going from 0 to 6. We don't want either one of their y coordinates. We want the y of the midpoint. So we want the y coordinate 3. So our first rectangle has a height of 10.4. How about the height of our second rectangle if we're using the y of the midpoint? 11.2. And the third one, 11.3. And then 10.2. All right. When you do this, this one had a decimal, right? Wasn't this a, what did this turn out to be? 258.6. Now, for the trapezoids, do these trapezoids have the same height if we're using 4 trapezoids? Yes. So what goes out front? 1/2 times 6. Now, we're allowed to do that doubling the internal ones because we pulled out the common height. So, but we have to only use the ones we need. So what's the first base going to be, the one we have to? 9.6. Oops, 9. That was weird. 9.6 plus 2 times. You guys are so good. All right, what numbers go in here? What is it? The 10.8 plus 11.4, 10.7, close the doubling, right? So we don't use those midpoint y values. And then the last one is the 9.6. I don't remember what this one comes. And if you do it, I think this one I have here. Like I was just trying to copy and paste. Wait, I know this will make it clear for you kids. Does this come out to be 255? 255? Yeah, I'll just go back to what I had. This is 255. So you're going to do 3. Oh, no, we can even start 3. I want to look at it together. I don't want to waste a moment with you kids. Oh, no, it's another table problem. Why would I give you another table problem? What's different? All the widths or heights, depending upon what you're talking about, are different. So you got to do everybody separately. No, these are the easiest ones to do because you get to use these subintervals. Right? Oh, give me a break. Okay, first rectangle. The t values, which are like your x values. What's the width of the first rectangle? 2. Uh-oh, what am I going to use for the height? I see 2 y's there. The left one, so you're going to use the 1. You have to use the y coordinate on the left. Kids, I swear. All right, so 2 times 1 would be the area of our first rectangle. All right, moving on to the second rectangle. What's the width? And we're going to multiply it by -3, the y on the left. We're doing the left thing. The next one, 1 times 0 plus 3 times 2 plus 5 times 5, right? Yeah. Wait, why did I do a parenthesis there? Oh, well, I'll do 5 times. Because people think my times is a decimal, and I have to use the parentheses. Now, it's funny with these. You wind up getting the same answer for each one of these. You do, and that's just a crazy coincidence. I happened to guess, like, it's not like they're always the same. But you should still go through the work tonight. What is that answer? It is 21. And when you go through, do the work tonight for the other ones. Make sure you can get 21 for the other two. And if you have any questions, we can go over it tomorrow. Remember with the TAM, you could only pull out the half if they don't have the equal heights, right? This is going to be good. You're going to look it over tonight. You're going to love it. All right, guys. I'm here after school if you need me. Yeah. Bye.